This conference will now be recorded.
Okay, so the
Yeah.
binders algorithm is a basic concept learning algorithm in machine learning, okay,
Okay.
which is to find the most specific hypothesis that fits all the positive examples.
Okay.
Okay, for general hypothesis, we represent as a question mark, and for the specific hypothesis, we represented by phi. I'll just show you the algorithm here.
Symbol 5.
Yeah. Yeah, I can see here. See here, for general hypothesis, we represented by question mark, and the for specific hypothesis, we represented by phi.
Yes.
And this algorithm is applicable only for positive examples,
Okay.
not for the negative.
Okay.
Okay, remember that condition. Now you can see, first we have to start with the we have to start with the most specific hypothesis.
Okay.
We need to consider as a phi, the first most specific hypothesis. So they will be giving a set of training data. So in that we will consider the first value, the first attribute as a most specific hypothesis. I'll show you here. I'll take an example. Now in this example, this is the data set.
Yes.
So they have given for the data set about the particular seeds or whether it is poisonous or not. So now if the color is green, if the toughness is high, if there is no fungus, if there is appearance of wrinkle, we call it as poisonous.
Okay.
S means positive, no means negative. For no we cannot do it. Only for S we can do it using find S.
Okay.
So first we need to consider the most specific hypothesis. So we will consider as the first example. This is the most specific. So what is the most specific? Green, hard,
Green,
no,
hard,
wrinkle.
cold.
This is the for example. Now see here. So first we'll consider green, hard, no, wrinkle. Now consider second example is what? Green, hard. Again, because the second one we cannot consider because this is no. Right, and this also I cannot consider because that is also no.
Yes, third one is also non-poisonous.
Now I need to compare first and fourth.
Okay, color is only different.
Color is changed because it is orange. So we'll make it as question mark. And for other we write it as same because soft is because that is also hard, no, and wrinkle. Now see here, only orange and green has been changed. Here also hard, here also hard. Here also no, here also no. Here also wrinkled, here also wrinkled.
Yes.
So now wherever there is a change, we'll mark it as question mark. Now you can see here.
Yes.
Okay, the question mark means is a general case. Okay.
Yeah, it becomes general.
General. Next.
Yes.
Go to the next example. Now you have to use this updated value. This is our updated value. Okay.
Yes.
Now we have to compare this with the next example, not with the first one. Now if you see the fifth example, now this has been changed, right?
Yes.
This is also change.
Yes.
This is also change.
Yes.
This is also change.
Yes.
Now we got all question mark now.
Correct.
No problem. If you compare with 6 and 7, all will become question mark only. Because when we compare 4th and 5th, we got all general.
Uh-huh.
General in the sense whether it can be green, whether it can be orange, whether it can be hard, whether it can be soft, whether it can be yes or no, whether it can be smooth or wrinkled. So we call it
Yeah.
as it is a poisonous.
Uh-huh.
So now you can see here. See, we all got question mark, question mark, question mark, question mark. So the final
Yeah.
hypothesis what we have got question mark, question mark, question mark, question mark.
Uh-huh.
It means so it can be anything we will consider as poisonous, no matter what.
Uh-huh.
And what will happen in some example you will get question mark, and here you might get S, and here you might get wrinkled, which means this two can be anything,
Uh-huh.
but this two has to be S and has to be wrinkled. Then only we call it as it's a poisonous.
Okay.
Otherwise, we'll say it is not.
Okay. Got it.
Understood now? See, one thing you remember here, when we compare the more specific hypothesis, if the values are same, we will not make any changes.
Right.
If the attributes are different, we'll change this to question mark.
Yes.
Okay, understood now?
Okay. Yeah, understood.
Can you give an example? Will you do it?
Yes, you can. I can.
Okay. I'll give one data set and you have to do it.
Uh,
Okay, you do it for this example. Write down this training data set and try.
uh,
Okay, I'll give 10 minutes
yeah.
and tell me the final answer.
Yeah. I'm noting the example.
Okay,
One thing I wanted to ask here. Makdoum. One thing I'm not clear. Like here, the first two parameters are the same for the first two. The third parameter is different. Hello.
Shailesh?
Yeah. In this example,
Okay.
We start with the first row. Then we compare with the second row. The first two parameters are same. The third one is changed.
We'll write it as question mark.
So that 5 question mark 5 that is the first outcome, right?
Yeah, this is the what in the place of 5 you have to write these values. Sunny, warm, question mark, strong, warm, safe.
Warm. Okay, then we enjoy. You can say we we are enjoying the sport.
Yes. And the third is we cannot because that is no, because that is a negative example.
Third, we have not to consider. So, okay.
Now compare the fourth one with second.
Oh, just a minute. So there also. Once we have got this question mark, it will remain question mark, right?
Yes, yes.
Okay. So then strong, then there is a change in water. Water is changed, so that becomes question mark. And the forecast is also a change, so that also becomes question mark. So the final thing is sunny, warm, question mark, strong, question mark, question mark.
Which means now the first parameter has to be sunny. Second parameter has to be warm.
Air temperature should be warm.
Yes, and humidity it can be anything. Either it can be question mark.
Wind,
It can be normal or high. Anything is fine.
uh,
And the wind is always strong.
wind should be strong.
And
And water can be anything. Forecast
yes,
can be anything.
yes, good.
Yeah.
Understood, right?
Yes, understood. With this example, like more clear about the algorithm, how it works.
Yes, good. So this is the we call it as the basic
Find us.
find. Can see the answer here. That's what you have got. Sunny, warm, question mark, strong, question mark, question mark.
Yes.
Okay, so now we'll see Naïve classifier. Okay.
Okay.
Okay, so basically Naïve classifier is based on the Bayes theorem.
Yeah.
Okay. So this is a formula for that, like P of H by D is equal to P of D by H into P of H divided by P of D.
Okay.
So what is P of h by d means? It's a probability of hypothesis for the given data D.
Okay.
This is called posterior probability.
Posterior probability. Okay.
Okay. Next is P of d by h. This is a per year probability, which means the probability of data D given the hypothesis H was true. P of H is a probability of hypothesis, and this is a probability of data.
Okay.
Okay, it's being true. So now, first we calculate the posterior probability for the different hypothesis. See, there can be a different hypothesis, not only one. We might have a multiple hypothesis, and we have to find the most probable hypothesis for the given observed data. Okay.
Okay.
For given data, now, like it will calculate the probability and it will predict the model. Okay. So you know what is probability?
Yes.
Probability is
Like
equal to what?
the probability is like the possibility of the particular outcome of an event.
Yes, yes. One second. We'll take one example here. Now, if you see this data set, now the data set is for, like, they have given the pregnancy 6, glucose is 140, some values are there. Okay,
Right.
and we have to see the outcome 1. So now, okay, let me take the simple example first so that you will understand. I will take it as this classify. This is a classifier algorithm, okay? So this is the most commonly used data set. This is the very important data set. Now see, they have given the color and they have said the type and the origin. Based on that, it is saying that whether that particular, we can call it as, car, record theft problem. So we have to say whether it is stolen or not.
Right.
So they have given the data. So first we have to calculate the probability of S. Okay. Now how many data set are there? 10.
10 is
And out of 10, how many S are there?
5.
So 5 divided by 10. What is the probability? 0.5.
0.5.
And next you have to do the probability for no.
That is also 0.5.
That is also 0.5. So now first, for the S, find the probability of red. Only for red color. Now if you see red, so how many S are there for red? You have to check. For S we are doing. So 1, 2,
2 and 3.
So out of 5?
3 are there.
So 3 divided by 5.
0.6.
Next, again do red for no. We will get 1,
2 by 5. 0.4.
Yes. Next, go to type. So again, color is yellow. That is for red we have done it, right? So now do it for yellow. Same way. Yes and no.
Yellow we have 2 of 5 as yes, and 3 of 5 as no.
Good. Now go to type. First do it for sports. For
Okay.
yes.
For sports, 1, 2, 3, 4. 4 of 5 for sports.
Okay. And SUV?
SUV.
First do sports for no also.
For sports, no, we have just one of 5. 1 of 6. Sorry,
Now,
1 of 5 for
yeah.
yes.
Now next is SUV, same way.
SUV, we have
1 of 5.
1 of 5.
And no is 1 of the 3 of 5.
Here one thing, one small doubt. Like in the sports, we have 6 sports and 4 SUV. In color,
So
we had all 5, 1, 5. So whether we have to consider only for stolen uh, as a reference, or we can have to consider type as a reference.
type as a reference, you cannot consider that one. Let it be 4 or 5, because if when you do S, you have to check how many S are there. That is,
Okay,
you have,
okay.
okay. So now same thing, origin. Okay. So now here they might ask one question here. There we have to classify. We need to classify if the car is stolen given the feature of car. When they're saying to we observe that a car is stolen if the color is red and type is sports, origin is domestic. So we want to classify the red domestic SUV only now, because we need to consider the first hypothesis. No, now for red, sports, and domestic. Okay. Now first you the probability of S.
Yes, is 0.5. Probability of
Yeah.
yes is 0.5.
All no, you have to like this. You have to do it. Probability of S means probability of S into probability of red into S into probability of sports into S into probability of domestic into S.
Okay.
You see the value, what value you will get for that. Okay, and then do it. No, probability of no into probability of red no into probability of sports no into probability of domestic no.
Yeah, okay.
Now you check which value you have got more. Which you have got more. So we say if you have got S more, so we'll say the car is stolen. If you have got the probability more for no, we say the car is not stolen.
Right.
Now you can see here that example they have showed how to
Yes.
calculate 3 by 5.
Yes.
No, 3 by 5. Same thing you have to do it for sports and SUV, and then you have to do it
SUV.
for domestic and imported.
Imported
Now,
and
yeah, this is a
domestic.
new data which have come now. We need to check whether this is stolen or not. So how will you do it? As I said, probability of red S into probability of SUV red S into probability of domestic S and probability of S. If you
Yes.
multiply all, you will get 0.048.
Okay.
Same thing, we do it for no. You get 0.144. So which is more?
0.144.
Yes. So we'll say that the whatever the data have come, which means the car is not stolen.
Not so.
Got it?
Yes.
This is how you have to do it. So can I give one more example? Will you try it now?
Yes, I can try.
Yeah. I'll write this and try for this example. Now whether you this is the question and you have to do it for the probability. This is your the last predictor. This is the 4 inputs which you need to predict whether it belongs to S or no.
Right.
And this is a data set. Okay, try it. I'll give 1 10 minutes for this. I think you have to use calculator if you have. Better use calculator.
Yeah. Yeah. I have this not normal calculator.
Yes, normal is it's fine because we are not using any logarithmic. We just have to calculate the probabilities for all.
uh,
This is for weather forecast.
uh,
Okay, once again, first you write down this, Shailesh.
uh,
This one you read the fourth input for which we are going to predict. So outlook is
okay.
rain, temp is cool,
Uh, Outlook is rainy, temperature is cool,
humidity is high,
humidity is high,
windy is true,
windy is true.
and you have to find out the play whether it belongs to S or
Uh,
not by using
Humidity, Naive Bayesian classifier.
yes. Do it.
Okay. So first, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 data set. 3, 4, 5, 6, 7, 8, 11, 12, 13, 14. This is 1, 2, 3, 4, 5, 6, 8, 9, 9 and 14. Yes, 9 by 10. No, yes. Yes, 5 by 10. So, outlook. Rainy and overcast. Rainy, sunny and overcast. Rainy. Rainy 1, rainy 2, 4, 9. 1, 2, 3, 4. Overcast 4, 9, 5. 1, 2, 3, 9, 6, 9. Temperature. Hot, mild, cool, mild, cool. Hot, summer. Mild, 3, 4, 4 of 9.
Shailesh, you
Ah, ah.
tell like you are in which room now? Were you doing which attribute?
I'm doing for the temperature.
Okay. Tell me the final value, and I'll tell you which is whether it belongs to yes or no. Okay.
Yeah. Another, I think 1 or 2 minutes. 2 minutes.
Okay. Fine.
Okay. Sorry. One thing.
Yes.
Like, yeah, for say temperature. We have say hot. Hot
Mm,
is two. Two which are
yes.
yes, and
Yeah. So 2 divided by how many s are there? 1,
9. Uh,
2,
and
1.
and no, like that way we have to find for no also, right?
Yes.
One, two, one. But here there is small difference. Like the earlier example we had all that outcome was same, like 5. Here
No problem. No problem.
outcomes.
No
Here
problem.
is one. Here one is outcome is first yes are 9 and no are 5.
No
So
problem. No. You have to consider
when
9 only.
no, just a minute. What I'm trying to understand is when I am saying hot and no, then
Okay.
the probability should be uh, 3 of uh, 3 of 5 when I consider no.
Not 3. 2 no. We have only 2 no for hot.
Yes, too hot for no, but like we have 5 no's, so
2
uh,
by 5.
two of 5 is the probability, right?
Yes.
Oh, okay, because that is a little bit change was 2 of 5. So I was putting 2 of 9. Oh, sorry, yeah, I have to rework that
Yeah.
way.
Okay, no problem. Take your time and do it.
One, two.
Did you got Shailesh?
Yeah, just for windy conditions, I'm going through it.
Okay. We do it for true.
Outlook, temperature and humidity I have done.
Okay. Do it for windy.
Uh, Windy is true and false values, right? So 1, 2, 3, 4, 5, 4. False, 6, 9. False, no, 1, 2, 2, 5. And true is 3 of 9 and 3 of 5. Okay. Okay, so I have all individual probabilities and we want to find for rainy, cool, high and true.
Yes.
Predict
Now,
for
you do
rainy.
it for yes as well as you do it for no. We multiply all the values of s.
So multiplying all values for rainy, yes, is 2, 9 into cool, cool is 3, 9 and humidity high is again 3, 9 and windy true is again 3, 9. So 3 by 9. 0082 into 0082 into one thing for probability of yes was 9 by 14.
Yes, yes.
So that we have to consider.
Yes, yes. We have to consider that also.
So it is 0052.
Yeah. 0 point
0.0052.
for yes, sir. Do it for no.
Okay. So for now,
Good.
no. So 3 by 5 cool is 1 by 5. High is 4 by 5. I know. And true is 3 by 5. No, and now is 5 by 14. 3 by 5. 1 by 4 by into 3 by 5. 5. Yeah, so it is 0.02
Yes.
0.05.
Which has a probability.
No has higher probability.
So we consider as the data set which we have given, it's a plague wolf is no, belongs to no. So we will consider which has the higher probability value.
Right. Okay. Here in this case, it is no.
So see here in the machine learning. So what basically we do is the input will take it as a data set every time.
Yes.
So which means it's a CSV file because when the data is stored in the form of rows and columns, we consider as a CSV file.
Yes.
So always you have to work with the CSV file and then we'll write the code in Python. Now first what I want is I want you to understand all the basics algorithms of machine learning. Then we can implement one by one using Python.
Yes.
So you'll get a clear idea now. It's okay. So when you learn this complete machine learning, you can directly apply for machine learning developer job as well.
Yes.
Some company people
Yeah.
will take it as a machine learning developer and then they will train you over that.
Right. So
Okay.
this is good learning today.
Yes.
Yeah.
Okay. So Naïve's classifier, find a algorithm, and then is now what we do is tomorrow also we do this algorithms, other two algorithms. One is k means nearest algorithm, k nearest neighbor, and then one more we have to learn, I guess, linear regression and this one. Linear regression, k nearest neighbor algorithm in Python. This is and regression algorithm. This two is enough. Okay.
K nearest
Neighbor algorithm.
K nearest neighbor and regression.
Regression, linear regression.
Linear regression. Okay.
See, everywhere data set is important.
Yes.
So once I explain the algorithm, then we'll start with see. You can see here in every code they have used NumPy and Panda. So that's why once we complete the algorithms, then we start NumPy and Pandas. I think it will take 2 sessions. One session NumPy and one session Pandas.
Okay.
Then after that we can implement all the algorithms.
Yes, in Python we can implement.
Yes. And already you have basic knowledge of Python as well.
We understand the logic of the algorithm. We can implement it.
Yes, yes.
Okay, so today we will be going through this or the next class.
What we do, if you want, we'll do now. Otherwise, we can first practice those two. Next session, tomorrow we can do these two algorithms.
Yeah. Okay. Okay. We can. I'll find some more data set example and do some practice so that gets more insight.
Yes, tomorrow we'll do k nearest and the linear regression. I'll explain that how the linear regression will work. So once done with that, we can start with NumPy and Panda. Once we complete that, and we'll do the complete machine learning concepts implementation using Python.
Okay.
Okay, Shailesh.
All right.
Thank you. Bye bye.
Oh, thank you so much. Yeah.